Assalamualaikum. Today we will see another problem solving video on topic hydrostatic force on an inclined plane surface. Let's see the question. Here said that a homogeneous 4 feet wide and 8 feet long rectangular gate. This is a rectangular gate which is wide for 4 feet and the length is total 8 feet. Weighing 800 lb is held in place by a horizontal flexible cable as shown in figure. This is a horizontal flexible cable and this gate is placed with this cable and the weight of this gate is 800 lb. Water acts against the gate which is hinged at point A. This is a point A, this gate is hinged here and it can move like this, and this is the watery surface. Here the friction in the hinge is negligible. There must, in real life, there must be a friction in moving in this hinge point, but here said that the friction is negligible for this method. So we have to determine the tension in the cable. This cable might have a kind of tension force working towards this for the gate, because the gate is attached here with this cable. So the cable tied the gate here and the tension force will work towards this. Suppose this is T. This is the tension force. We have to find out this. At first, let's find out the hydrostatic force. The watery surface must have a force applying a force on this gate. Suppose this is our that hydrostatic force Fw for the water. Why I draw this force in this angle? Because we know that the force always work upon the surface at perpendicular. This is the perpendicular with our gate. So the force working like this way, and they said that this angle is 60 degree. See, if we have draw a horizontal line, this will be 60 degree. Let's find out this force. So this hydrostatic force will be pressure force into area. Pressure equals to rho GH into area. Area means the area of this gate, which is 4 into 8 because it is rectangular. And rho equals to the density of the water, which is 1000. G equals to 9.81 and H is the centroid, means that the distance from this watery surface to this point at where the hydrostatic force work. This will be H from this distance, and as it is the point of centroid of this gate, so it will be the middle point. Our watery surface is 8 feet, that's 8 in the question, because this is the gap and there is no water. So from here to here is 6 feet, and the centroid must be at the middle, which is 3, at the point of 3 feet. But this creates the angle theta, and we have to take the vertical distance from watery surface to the action of force. So this portion will be 6 divided by 2 into sine theta, where this theta equals to 60 degree, into area equals to 4 into 8. Why we have to take the sine theta? But if we divide this into our two portion, horizontal and vertical, and this angle is theta, so as we need this side, so we have to take the sine theta. And as our these data are in foot lb, so we have taken the value in lb per foot cube. So the answer of this will be 62.42. this is in lb per foot cube into 3 sine 60 degree into 32, and our final answer will be 3895 lb. This is the hydrostatic force. And now we will find the point where our hydrostatic force at works, not the centroid. This is the point where all the pressure force work, which is H star. We have already know the formula for an inclined surface. H star equals to, this is the formula that we have already from the previous video. Here, distance of centroid from the free surface, this H. So we have already find out the H, which is 6 divided by 2 into sine 60 degree. This is 2.6 foot. So we will use this value 2.6 plus Ig. This is the moment of inertia about the point centroid. So as our gate is in the rectangular shape, so the formula of centroid moment of inertia of the centroid will be 1 by 12 into b into a cube. We have used the a as 6 because our watery surface is only 6 feet and this is the gap. So we will use this value to find out the moment of inertia about the centroid, which is 72 foot cube. We will use this value here, and our age is 2.6 and area is 4 into 8 into sine 60 degree square, and the final answer is 3.465 foot. This is our H star. We have to find out the tension force that working in this cable. How we'll find this? Suppose this is point A and we will took the moment at point A, and for taking the moment at point A we have to see what type of force works in this figure. This is our one force, that's it's the hydrostatic force. This is another force, this is the tension force, and the gate has a specific weight. This is also a force. So we have total 3 forces that working in this figure, and we'll take the moment of these 3 forces towards the point A. So the moment of about the point A, this is our one force. We will take this tension force and the shortest distance from the force towards the point. This is our point and the shortest distance is this portion. But we know this portion which is 8 feet, but we have to take this vertical shortest distance. So if we, as we know the angle theta is 60 degree, so if we divide this curved angle towards the horizontal and vertical, then this will be also theta, and so this portion will be cos theta and this portion will be sin theta. So as we take the value of this, we will take this as 8 sin theta. So force T into distance 8 sin theta. This is our one force. As this is anti-clockwise force, so we'll take this as positive. Now let's see the hydrostatic force. This work at this side. So as this is the clockwise force, we'll take this as negative, and we'll take the force Fw and the shortest distance from the point to this force. So this will be, we'll take this portion. Why we don't take the vertical portion? We take this curved angle because our force is acting perpendicular to our this gate. Our force is not straight. So if we count this force and this point, our shortest distance is this portion. So this will be our total water surface is 6 feet, and this point where our hydrostatic force is H star. So if we minus this H star from total distance 6, we will got this shortest distance. So this is the 6 minus H star. But look, our H star is the vertical distance, but if we directly just minus from 6 to 6 minus H star, we will get this vertical distance. We will not get this inclined distance, as we need this inclined distance, not this vertical distance. So we will took the H star divided by sin theta. This is the our H star, and we took the value of this portion. This is H star divided by sin theta. And our lastly force, the W, which is the force of weight. So as this is also the clockwise force, we will get minus before the force W into the distance of this force. Look, this is the shortest distance between the point hinge at A from the force W. So our obviously this weight is working at the middle of this gate. That gate is totally 8 feet and the middle of this gate is at 4 feet. And if we suppose this is our total 8 feet gate, and this weight is working at the middle of at point 4 feet, but we have to take this distance, and we know the angle theta 60 degree. If we divide this into this and this portion, then this will be our cos theta. So we'll take the distance as 4 cos theta equals to 0, and we know all the value except T. So if we calculate, then our tension force will be 1355.33 lp. This is the answer.